Okay, guys, so we're going to start the sensory system. So this is going to be a little bit different from the other systems. Usually we go through the names of things, and then after we're done naming them, we talk about the functions. Here we're going to name them and talk about the functions all at the same time. So you have guided notes through at least the I part of this, the first 20 or so slides. So if you haven't already, I would either pull up or print out those guided notes. They will help you immensely. So, sensory system are your five senses. So, your eyes see, your ears hear, your nose smells, your tongue tastes, and your skin has the ability to feel. We're not going to go into skin too much here because the next unit that we talk about will be the skin. So, we'll talk about it in depth there. Does anyone know what our sixth sense is? It's the ability to see dead people. Just kidding, that's a movie from the 90s. Highly recommend you see it. Super big twist at the end. Starting with eyes, and this is going to be the only part you have guided notes for. So these are the external part of the eyes, meaning things on the outside. So your orbital socket is the hole in your skull that the eyeball fits down into. You have eyelids, you have eyelashes. As far as conjunctiva, conjunctiva is a little membrane that covers the outside of your eyeball. It also is your eye pocket, eye sac. Okay, how do I say this? So if you like have to put drops in your eyeballs, you know how you like pull down on your lower lid and it makes that little like pocket that you can put the drops down into. That pocket is also that conjunctival membrane, your conjunctiva. I suggest you go look in a mirror and pull down on your eyeball. Nope, not your eyeball. You know what I'm saying? Just that bottom lid to see that little pocket that forms. That should be nice and pink, and that's one of the ways that we tell paleness in people who are darker skinned. So people who have a darker skin tone, when they have anemia or they're bleeding out, things that are affecting their blood levels, sometimes it's harder to tell just looking at their skin that they're pale. So we can look at their nail beds and we can look at that conjunctiva to see if they're turning pale. The next bullet point is lacrimal glands and duct. That's lacrimal means tear. So it's your tear gland. You can see that that's above the eye, way down deep. And then your lacrimal canal, meaning your tear duct, is at the inside of the eye. So you make tears and then they fall down and are constantly coating your eyeballs every time you blink. But if you make too much of them, they fall out of the eye, and that's when you're crying, quote unquote. Also, if you've ever noticed that your nose starts to run when you cry, it's because those tears drain down that duct and can get into your nasal canal. And then it says lastly, extrinsic muscle. So your eyeball moves because muscles pull it, just like everything else in your body. So you have some muscles that attach to the back of the eyeball. You have one like on the top and one on the bottom and one on the left and one on the right. And whenever one of them contracts, it pulls the eye that way. And those are controlled by those cranial nerves 3, 4, and 6. Oh, look at that. There's the muscles. So you see the top and the bottom, the left and the right, and there also has some for like rotating, which is weird. All right, so these are the internal structures. Don't forget, we're going to go through all of these individually. Sclera, choroid, retina, cornea, iris, pupil, lens, and ciliary body. So individually, starting with the sclera. The sclera is the white part of your eye. It's the tough outer, it's the, we call it the globe. It's the eyeball, basically. Think tennis ball, not furry like a tennis ball, but like about that. You can push it and you can make it give some, but it's nice and pretty firm. This sclera is what will turn yellow in people who are having jaundice when they're in liver failure. Then comes the choroid. So everything in your body means blood, and the eyeball is no different. So if you're looking at that picture on the bottom there, the white on the very outside, that's the sclera. That pink layer in the middle, that's the choroid. It's the vascular, meaning blood supply, middle layer of the eye. That yellow on the very, very inside, you're going to see is the retina. So the retina is the innermost layer, meaning it's the deepest. So sclera, the white part's on the outside. Then you have that choroid, that vascular layer, and then the innermost, insidest layer is the retina, which is yellow in that top picture. The retina is where you actually see things. So it has special cells called light sensitive cells, and we'll talk more about them in a minute. But basically, when light comes into your eye, it hits the retina. And so the retina then has specialized cells that interpret that light and send it as a nerve impulse to your brain, and that's how you see. So that's what it means where it says where light from objects forms images, and then those images are transmitted as nerve impulses by the optic nerve. If you'll remember, that was cranial nerve number 2. That's the one that actually lets you see. To the occipital lobe, which, if you remember, was the back lobe of the cerebrum, the wrinkly part, which was responsible for vision. So in that top picture, you see the yellow that's inside of the eyeball, that's retina. But once it like thickens up and leaves the back of the eyeball there, you see that we're calling that the optic nerve. So those specialized light sensitive cells are called rods and cones. So those are the next 2 things that we're going to talk about, but also I want you to see that the optic disc is on the retina. There's a lot of questions about the retina. It is very, 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 very important part of your eyeball. It's basically why you see. So we're going to talk a lot about it. So starting with rods and cones. So rods are the light sensitive type of cell that picks up dim light. So if you think about it, like when the sun is already set and there's barely any light outside, everything's kind of a shade of gray. So rods help you to see. We always think black and white, but it's not necessarily black and white. It's your shades of gray. So when you're driving late at night and you're trying to, figure out what's the road versus what's grass versus what's that deer coming across the road, those are rods that are responsible for that. So some people have problems driving late at night. They have a rod problem. Versus cones, I always think CO in cones is also the CO in color. So cones and color, because they are what picks up bright light. They're what let you differentiate all the different shades in the world. People who are colorblind, that's what they have. They have a problem with their cones. So if you can't match clothes to save your life, maybe it's not that you don't have a good fashion sense. Maybe it's that you have a cone problem. Optic disc is, so if you look at that picture to the right, the yellow circle that looks like it has all the lightning strike things coming out of the center of it, that yellow circle, we call it the optic disc. A lot of people call it your blind spot. So everybody has a blind spot in each eye where you can't see things, but your brain just kind of blurs over it and figures out what's there. Similar to like how you can always kind of see your nose, but you don't really think about it and your brain just kind of ignores it after a while. Your brain's amazing. So the reason that you have a blind spot is because if you remember from that previous picture, let's see if I can show you. You remember the optic nerve coming off the back of the eyeball in that top one. So where that optic nerve meets up with the retina, if you see there's a little spot where there's not going to be any rods or cones because there's optic nerve. So you're seeing that circle is the optic nerve coming off the back of the retina. Because there are no rods and cones there, you can't see there. And I usually have you do a little thing in your textbook where you test and find your blind spot. I can't do that because you're at home and I'm at home too. I'm sure there are like blind spot tests that you can Google on the internet. I think it would probably be pretty hard to do with a computer screen, but I'll see what I can find for you. Last thing I want to go over is called the macula. So sometimes the macula is called the fovea. So if you see it labeled on the picture there, it's kind of that darker spot that they're calling the fovea. Usually we call that the macula. So it's kind of the opposite of the blind spot. So the blind spot was that spot where there are no rods and cones, and so you can't see anything in that tiny little area. The macula is where there are the most rods and cones, and it is responsible for your sharpest vision. So that's the spot of the retina that picks up what you're looking straight ahead at. And if you think about it, the reason that we look straight ahead at things is because we want to see them clearly, right? So if someone's standing like to your side and they're talking to you and you want to see them really well, you don't keep staring away from them, you turn and look at them. And the reason that we do that is because that's where we see the clearest. And the reason that we see the clearest there is because there are the most rods and cones on the spot of the retina that lines up with that ray of light. And we call that spot on the retina the macula. All right, so now we're talking about the cornea. It's the thing at the very, very front of the eyeball. So you can see it's highlighted in yellow, the cornea. A lot of people call this the window of the eye because it's I kind of think of it as the windshield of the eye, but it's the clear center circular part at the very front of your eyeball. So it's kind of miraculous. The sclera, that white part, um, all of a sudden at the very front of the eyeball, it stops being white and it starts being see-through. It starts being transparent. And so we stop calling it sclera and we start calling it cornea. A lot of times when people get their eyeballs scratched or things like that, something I had a kid one time set off fireworks at my feet, and one of the little metal pieces flew up and gave me a corneal abrasion. Abrasion meaning scratch. So a lot of people, when they scratch their eyeball, they scratch that cornea. It's very, very, very uncomfortable. Trust me. Next comes the iris. So the iris is a color. I think it's like light purple or something. Don't yell at me, art people. I may be wrong. And so it is the colored part of your eye. It's actually a muscle, which is really cool. And we're going to talk about the pupil is in the center of it on the next slide. So the iris is the colored part. The pupil is the black hole in the middle. I'm going to blow your mind for a minute. I know that you probably know that when you shine light in your eyeball, your pupil gets smaller, it constricts. The pupil is just a hole. It's just blank void nothingness, which is kind of creepy. It's actually the iris that changes how big it is to affect the pupil. So when the pupil gets smaller, it's because the iris actually got bigger. And when the pupil gets bigger, it's because the iris, which is a muscle, has contracted and gotten smaller. But we don't really talk about it like that. We talk about it as what the pupil is doing. That is an up close picture of a pupil. Isn't that creepy? Ew. I went to nursing school at UNCC and they had just built this gorgeous new building and they had these huge pictures. I mean, this would take up like a whole wall. And it took me forever to realize that it was an iris under high magnification. Okay, so I've already said it. So this was the iris, the colored part. This is the pupil, the black hole. And it really is just a black hole. There's just nothing there. Ew. It's how light gets in. So again, if you need to let more light in because it's dark outside, the pupil will get bigger to let more light in. And then when you shine a flashlight in someone's eyes, don't do it, take my word for it. The iris actually gets bigger so that in effect the pupil constricts and gets smaller. And that's controlled by the sympathetic nervous system, fight or flight. And then your lens. So this is the whole eyeball. Just this part right here is the lens. They bounce. Let me tell you how I know. In high school, I took anatomy and physiology, and I was in a group with two like super popular, cute jock boys, and they wouldn't dissect anything. I had to do it all. So I was dissecting a sheep eyeball or something like that, I think. And Dustin, one of the guys, picks it up with the little tweezers that we had. And it was the only thing he'd done the entire freaking class. Picks it up with the little tweezers he has and goes, ew, and drops it, just like lets it go. And it bounces across the table and lands on my hand. And I was like, tell me there's not a sheep lens on my hand. And Dustin just kind of looked at me and I was like, yeah, okay, cool. This is my life. So a lens in your eyeball is just like a lens in a camera. It changes shape. So like it will flatten out or circle up. Does that make sense? Like it will change how flat or how rounded it is here. And it does that in order to focus light because light's coming in from all these different angles and it's coming in from everywhere. And your lens focuses it to shine it on the back of the eyeball. And it does that, it changes based on how far away you are and how much light you're getting. So it focuses whatever light is coming in so that it hits the back of the eyeball just how it's supposed to. This is also kind of, think of like how the diaphragm divides your thoracic cavity from your abdominal cavity. This lens is the point at which we call everything in front of it the anterior, meaning to the front of, and everything to the back of it the posterior chambers. Ciliary body are just these are little ligaments that hold the lens in place. This lens needs to be right in the center, but it can't just float magically. So these are little ligaments that hold it into place. Now, your eyeball is water filled, it's not air filled. So, the front of the eyeball, everything in front of the lens, is filled with something called aqueous humor. So, if you think of aqua, it's like aqua. So, this is watery. This is constantly being made and kind of draining off and made and draining off. And just like we studied hydrocephalus, there's a condition where if you make too much of it or it can't drain off, it causes problems. And that problem is glaucoma. I got the glaucoma. In the back of the eyeball, it's called vitreous humor, and it's no longer watery, it's jelly. It's a jelly-like fluid. So while the aqueous, the watery stuff in the front is being made and draining off constantly, the vitreous humor, the jelly that you got, what you got is what you got. It's never going to make more, and it shouldn't ever drain out. As you get older, sometimes this will kind of dry up and shrivel a little bit, just like everything else in the body, and it can cause some vision problems later on in life. Okay, so here's how we see. We see because of light. Don't get too bogged down in this. Just know that like light, you flip on the light in your room, right? And so then light comes into your eyeball. What it does is it goes, first of all, through that windshield of the eyeball or window, the cornea, the clear part at the front. Then it goes through the hole, the pupil. Then it hits the lens. The lens refracts it. The lens focuses it. The lens bends the light to make it go where it's supposed to. Then that light technically goes through the vitreous humor, but don't worry about that. And then it hits the back of the eyeball, which is the retina. Rods and cones are the little light sensitive cells on the retina that pick up that light and convert it to a nerve impulse because they're magic. That nerve impulse then goes via the optic nerve, crosses over to the other side of the brain. If you've ever heard that things that you see with your right eye are actually picked up by the left side of the brain and vice versa, and then goes to the occipital lobe. Now, your brain is really complex. So, like if you're staring at someone's face and it's taking up your whole vision, the outside of their face, the ears go straight back. So, like they don't switch over. It's just the inside of the face will switch over and go to the opposite side of the brain. And then your brain just like unscrambles it and figures it out because it's the best jigsaw puzzle solver in the whole wide world. Also, can we just talk about how puzzles are like $50 in the Corona apocalypse? This is the weirdest apocalypse. I thought like food would get expensive, but no, jigsaw puzzles got expensive. That's some crap. And this is the picture that's at the top of that worksheet. If you can't print it out, it's okay. Try to type on it if you can't, that's okay. Like it'll be all right. It's the apocalypse, deep breathe. So this is pointing to those little ligaments that hold the lens in place. This is pointing to the cornea, the clear part. This, because it's pointing to a hole, is the pupil. This is pointing to this chamber, so it's the aqueous humor, that's that watery stuff that's filling that up. This is the iris. This would be the colored pretty part. This is the lens, the part that bounces when Dustin drops it, and it also bends light. This whole thing is the vitreous humor, the jelly stuff. This one was pointing to the white outermost part, so that's the sclera. This is pointing to the middle layer, so this will be the choroid, which is the vascular layer. It's what's giving blood supply to the retina because everything needs blood. And then this, you can't tell because it blends in, is pointing to the innermost layer, that black layer, which is the retina. And this is the optic disc right here on the retina. So this will be your blind spot. Any light that hits right here, there are no rods and cones here. There is a nerve, but it doesn't have rods and cones on it. So that's your blind spot. And then it keeps on going back and there's the optic nerve. This is where your eye notes stop. If you want to pause for a little bit and fill those out and figure all that out, that's cool. But we're going to knock out names and functions for ear stuff today as well. So I'm going to keep going. Ears, oh my God, baby ears, they're so cute. Okay, so structure, just so you remember how like in the skeletal system, it's axial or appendicular and like everything in your body is like thoracic or abdominal or blah, blah, blah. We love sections of things in anatomy. So everything in the ear falls into either the outer ear, middle ear, or inner ear. And you've probably heard this that someone has like a middle ear infection or something like that, or inner ear, sorry. So this all is outside, but guess what? So is this. So one of the trickier things is that the outer ear goes all the way into the tympanic membrane, which is the eardrum. Just this little part right here is going to be middle, and then all of this is going to be inner. And we'll go over that in detail. Just hold on to it. I also want you to notice that, look, your middle ear connects to your throat, your pharynx. And we'll talk about that in a little bit as well. So obviously functions of the ear are hearing, duh, but also balance. Anyone ever heard that like your inner ear controls your balance, and when you get an ear infection, sometimes you feel woozy and off kilter? Well, that's why. And we'll talk about all that. So your outer ear. Outer ear, first, when I say ear and you think of an ear, we call that the pinna or the auricle. Both of those names are commonly used. You should probably know both of them, but if you want to pick one to be your favorite, I usually call it the pinna or auricle. I don't know what I usually call it. I call it ear, to be quite honest, but it's the pinna or the auricle. All of this stuff is pinna or auricle. Basically, it's a funnel. Its whole job is just to collect sound waves and funnel them in. Then you have your auditory canal. This is your auditory canal. Notice that it says external because some people will call that little tube that I said connects to your throat, that will also call that your auditory canal. That tube is usually called the eustachian tube, but some people want to be difficult. So if you want to be real specific, this is the external auditory canal. This is what you can but should not put a Q-tip into. Just so you know, you see this word ceruminous. I can't say that word to save my life. Ceruminous glands are earwax glands. So cerumen is earwax. It's a fancy word for earwax. So you have these special little cells in your external auditory canal, your ear tube, that make earwax. And it is protective in nature. You are not supposed to ever put anything into your ear canal. That being said, I absolutely do, and I try not to be a hypocrite, so I'm going to own up to that, but you're not supposed to, because it can damage this. You can accidentally poke through your eardrum, all sorts of reasons, but I still do it. And then comes your tympanic membrane. Fanciest name ever for an eardrum. It literally is a drum. So you see this right here. This is your tympanic membrane. It is still part of the outer ear. Even though it's pretty deep on down in there, it's still part of the outer ear. And that's one of the trickier questions that the curriculum will always ask. So it's literally a drum. So I am talking right now. That is being funneled in by your pinna. I think I do call it pinna. It's going through this external auditory canal, and it is literally assaulting your tympanic membrane. It is hitting your tympanic membrane. And just like the top of a drum, your tympanic membrane vibrates. And that vibration is how you hear. So we see because of light, we hear because of vibrations. So next comes the middle ear. So this was the pinna, the ear canal, and then your tympanic membrane would have been right here, but they didn't draw it. So when that tympanic membrane, that eardrum vibrates, the vibrations kick these three little bones. All three of the little bones together are called ossicles. But if you want to name them individually, and you're going to have to, we call them malleus, incus, and stapes. I always think Miss, like Miss Michael, M-I-S, Miss. Malleus, incus, and stapes. And I learned them in that order as well. They have nicknames. The malleus is called a hammer. Okay, maybe. I don't really see that. Incus is called an anvil. They really missed an opportunity to call this a chicken wing, because obviously that's a chicken wing. And the stapes is called a stirrup. Now that one I get. Stirrups are like what you put your feet in on the saddle when you're riding a horse. So yeah, get that one. So malleus, incus, and stapes, or if you want to talk about them all together, we call them the ossicles. They are the only things that are in this middle air-filled section, except that eustachian tube. So remember I said there's a tube that connects your middle ear down to your throat. This is how, if you've ever gone in an airplane or driven up in the mountains or dove, swam down real low when you're swimming, like snorkeling or scuba diving or whatever, the air pressure changes, right? And so you'll feel like your ears need to quote unquote pop when the pressure here hasn't equalized to the pressure outside in the world, on the top of that mountain or way down deep in the ocean. So what you do is what? You chew gum, or you plug your nose and try to blow out, or you talk or yawn, something like that. And that's because moving the back of your throat opens up this eustachian tube and lets the air pressure in your throat, which is the air pressure in the outside world, equalize with the air pressure in that middle ear. And that's what we think of as our ears popping. I can't do that. It will eventually do it, but I can't do anything to make it happen. And for that reason, I'm not ever allowed to scuba dive, which makes me a little sad on the inside. These bones are tiny. They are the 3 tiniest bones in your body, and they're legit bones, guys. They're like real bones. So just to show you how tiny they are, oh my God, look, all 3 of them would fit on the face of a dime. They're like little baby bones. They're precious. Okay, moving on. So now we have the inner ear. So pinna, outer ear, auditory canal, outer ear, tympanic membrane, outer ear, malleus, incus, and stapes, I guess, and eustachian tube, middle ear. Inner ear is just cochlea, which is this thing that looks like a snail. I think cochlea means snail. So I'm gonna Google that. And then here are your semicircular canals, half circle canals. So just this blue, teal, green, I don't know your computer settings. I don't know what color is showing up to you, but just this right here is inner ear, just those 2 things. So cochlea is how you hear. So I'm talking, it's vibrating, it's vibrating, it's vibrating, it's vibrating, makes drum vibrate, kicks this bone, kicks that bone, kicks that bone. That bone, the last one, stapes, kicks the cochlea. And so it makes the cochlea vibrate. Now, inside of the cochlea is fluid. And inside of those fluid are these magical little unicorn hairs. And those hairs, much like seaweed, drift back and forth when you kick the cochlea. And that movement of those hairs in that fluid is what your brain picks up as sound. So when those cells move, when those little magical unicorn hairs, which I should tell you are not actual unicorn hairs, I had someone think that one year, so I have to put that disclaimer on there. When they vibrate back and forth, your acoustic nerve or vestibulocochlear nerve picks it up and sends it to your temporal lobe in your brain. And that's what my voice is right now, kind of creepy. So if you've noticed, we've only talked about hearing so far, and I said that it was also balance. Well, semicircular canals, these little things that look like the scariest roller coaster ride ever, those do balance. So they are also fluid filled, and they have those same little magical unicorn hairs, but these hairs report back to the brain where your body is in space. So that's how, like, when you move and you're upside down or whatever, your body, even if your eyes are closed, knows something's up, and that's because of this. So you'll see that a lot of the disorders that affect your ear will present with dizziness as well. If it's an inner ear problem, it usually also presents with dizziness. I'm going to try to send y'all a picture of this. I usually have you trace it from your textbook and fill it in. But just so that we're all on the same page, number 1 would be your pinna or auricle, whatever you want to call it. I don't know why these are out of order and it bothers me. So then this, number 12, will be your auditory, external auditory canal. This right here, number 4, is going to be your tympanic membrane. And all of those things are outer ear. Now in the middle ear, number 3 right here is pointing to the malleus. Number 2 is pointing to the incus. And number 5 is pointing to the stapes. All 3 of those together are called your ossicles. And then this, number 10, is pointing to the eustachian tube or the internal auditory canal. All of those are middle ear. And now for inner ear, this right here is your cochlea, number 7. And number 6 is pointing to the semicircular canals. Then number 8 would be the nerve, the acoustic nerve or vestibulocochlear nerve, whatever you learned, that goes to the brain. And I believe, yep, that's it. Here's another way of looking at it. But again, it's just vibration. So sound waves, sound waves, sound waves, kicks drum, kicks this bone, kicks that bone, kicks that bone, kicks the cochlea. Oh, hey guys, look, here's the magical little unicorn hairs that move like seaweed, and then it gets sent to the brain. All right, guys, let me make sure. Yep, that's gonna do it for today. Miss y'all. Hope you're having a wonderful day.